All right. Well, now that you've got those slopes all figured out, it's time to do something with them. But first, we need to clear something up. And I'm just going to talk through number 2 here for you. So number 2 says, let the time t be 0 in 1950. What would the time t be in 2000? So t is going to be my input variable instead of x. So I'm going to be putting in t as an input and getting out some kind of gallons, I'm guessing, right? Because we're talking about gallons of beverages here. So what they mean here is the following. So when you figured out the slope, you probably put in 2000 minus 1950 in the bottom, and you got a number, but those are pretty big numbers on the bottom of your calculation there. And so what we're going to do to make our lives a little easier is do the following. So if my year is 1950, what this means, this is my year, and this is t. We're going to let t be 0. So there were 1,950 years before this, and even more for that matter, but we're not interested in any of them. We're only interested in 1950 and after. So we're going to call that year 0 because we don't have to worry about negative stuff because we don't care what people drank in 1949 or 1849 or any of those other years. So that means that 1951 is going to be year 1. And that means 1960 is going to be year 10, and so on. So these are, even though we put the actual years in the slope, that's okay. Whatever slope we got is still good. But moving forward, we're going to be doing graphs and making some models, linear models. We're going to be using t as my input variable, and t is going to look like this. It's going to be the number of years after 1950. So we're not going to be plugging in years into any equations moving on. We're going to be plugging in t, which is years after 1950. So this is what they mean in number 2. So now we're going to use the fact that this is a linear relationship to predict some values. So the only 2 years that we absolutely know the milk consumption for are 1950 and 2000. But they're asking us to calculate the milk consumption for 1985. 1985. And so in real life, we don't know exactly. This is probably not a precise linear model, but this linear relationship is probably pretty close to being linear. So we're going to use that to approximate what it is in 1985. So the first thing they do is let t be 0 in 1950. So that's t equals 0. So in 1985, what's t equal? What's t equal in 1985 if it's 0? So that's just the year thing. That's not the main part of this question. The main part of this question is to use the slope that you just calculated in number 1 there. And there's going to be a unit on that slope. And that unit is going to be important for you to figure out this next part of the problem. So you're going to use that unit, that slope, and you're going to figure out what this t is equal and how many years have gone by between 1950 and 1985. And one way or another, and whatever way makes the most sense to you, use that information to approximate the milk consumption in 1985. All right, so we're going to figure out how many years have gone by between 1950 and 1985. We're going to do some careful arithmetic there. We're going to take the slope in number 1 that has to do with milk consumption. And I'll give you a hint now, that should be per year, because years are on the bottom. X's inputs are always years, and inputs are always on the bottom. And it's going to be something per year, and that's going to help you get this answer to number 3. All right, so now comes the fun part. Now you're going to build a linear model for both milk and soda. There's going to be 2 separate linear models. Remember, these are 2 separate quantities we're tracking, so we're going to have separate slopes, separate models, equations for both of them. But we're just going to keep doing them both at the same time so we can sort of compare them. So remember, linear models are equations or formulas that are in this form here. Okay, and in this case, though, y represents the output, and in these cases, my output is going to be m or s, and that way we know whether we're talking about the output of milk consumption or the output of soda consumption. And the slopes are what you calculated way back in number 1. This x is going to be t, because that's what we're talking about. That's my input value, is the number of years that have gone by. So this is going to be t. And b, remember, is the starting value or the initial value or the output when the input is 0. And we are told right here that where exactly it is 0. So my b, my vertical intercept, as we also know it as now, is my starting value for both of these. And since we're starting in 1950, we just need to know what's going on in 1950 for this one here. So my equation should have a number here. This is the number you calculated in number 1. And this here is also some kind of value that you can get from somewhere. But then this should be, then it needs to still have 2 variables in it. So we should have a t right here and either an m or an s right here. All right, so we're going to come up with 2 equations or 2 formulas that will let us calculate the milk consumption in any year, t, or let us calculate the soft drink consumption in any year, t. And so here's something else you can do. So after you've come up with your linear model, let's say you have m equals, and then over here is some equation with a t in there and some other numbers. So this is a formula that should let you plug in a value for t and get an output for m. So here is how you can check to make sure you got the right formula. So we know, so there's a couple of values we know, right? We know what the consumption is in 1950. But we also know, if we go back to the beginning of this whole thing, we know what the consumption was in the year 2000, right? So 2000, we could plug that in there. We'd have to figure out, well, for the year 2000, that what is my t equal to? So you have to figure out how many years after 1950 that is. Then you could plug in 50 for that. And we are already told what the milk consumption is. So once you plug that 50 in, you should get the same number that we're told. If you got the right slope in there and you got the right b, the right initial value, you should be able to plug this 50 in and get this m that we've already been told. And it might be off a little bit if there was some rounding off in there with like the slope, but it should be pretty darn close. That's kind of a fail-safe way. If you plug that 50 in and get the right output, then you know you're on the right track. All right, so in these last couple problems, you're going to be using those models or those formulas that you came up with. And in this number 5 here, you're going to use them to fill in this table. So this t we've been talking about, they're saying, okay, t is 0 in 1950. So now fill it in for all these other values. Then you're going to use your 2 different models. One of them your m equals and your other one is your s equals. And you're going to plug in these t values into your formulas and then fill in the values. Fill in the values for gallons of milk and gallons of soft drink in this table. And these tables are going to help you with number 6, which has you drawing a graph. So you can start with those tables and draw a graph. And you're going to have 2 different lines here. And you're going to want to have those 2 different lines, both of them are going to be plotted on this axis here. And don't look too closely at where I drew those because they're not meant to be hints, really. But it's going to look something like this. So you're going to want to choose your scale, right? Because you're going to have t equals here, and you want to make sure that you have enough space to cover all the years that we're talking about here. So this is year 0, t equals 0 over here. So how far do we have to go? we have to count out our squares to make sure we can fit that in. And then on our vertical, we have, this is going to be gallons. And this will work for either soft drinks or milk. So we gotta figure out a nice scale for this here. And it's always nice if you can choose nice round values for these. You know, sometimes if you choose like 2.4 for each one, the math is going to get real ugly. But if you go 5 or 10 or 2 or 4 or 6 or whatever it is, it'll make the math a little easier. So you want to use up as much of this scale as you can, but you want to fit all of the possible gallon values. And then draw your 2 lines right there and then label them. Label them. So one of these is going to be, you know, milk, and one of these lines is going to be soft drinks. So put a label right up there telling what each one of those is.